I will start. Hello, myself Dr. Sangeeta Kulkarni, Assistant Professor in Chemistry, Government First Aid College and PG Center, Dharwad. Today I will start a discussion on the important class of what we call natural organic compounds called alkaloids. First, let us discuss about the occurrence and classification of alkaloids. So, alkaloids, according to Coyens, in 1880, he defined alkaloids as a naturally occurring organic bases which contain a pyridine ring. This is the example. According to Liedenberg, alkaloids are natural plant compound that have a basic character and contains at least one nitrogen atom in the heterocyclic ring. This is pilocarpine, an organic compound having heterocyclic ring with a nitrogen. This heterocyclic compound is a pyrrolidine ring which contains nitrogen. So, alkaloids simply are nothing but the basic nitrogenous compounds contains one or more nitrogen in the heterocyclic ring system having marked physiological action on human and animals when used in small quantities. This is how we can define alkaloids. Okay. So there are some facts and new evidences for the alkaloids. In 1806, pharmacy assistant Frederick William Sartner isolated morphine from the poppy seeds. This is one of the common plant, poppy plant, from which this was extracted. And famous Greek leader Socrates died when he was forced to take the drink of extract of hemlock containing quinine. And tobacco is one of the common narcotic alkaloid what we tell, which contain nicotine, is used as a very potent insecticide for fumigating greenhouses. Chiloptera used extract containing atropine to dilate her pupil in order to appear more attractive. Atropine in low doses dilates the pupils of the eye. So this is how these are some of the facts and new evidences for alkaloids. So some of the physical properties are, most of the alkaloids are crystalline solids but some are liquids. Example, volatile liquids are nicotine, quinine and spartine. Non-volatile are pilocarpine, hyoscine, etc. Majority of the alkaloids are colorless, but some are colored. Example, colchicine, berberine, canadine. So, berberine is yellow in color, canadine is orange in color. So, there are some colored alkaloids are also there. In solubility, the difference in solubility is used for the base of isolation and purification of non-alkaloidal bases. So, both alkaloidal base and their salts are soluble in alcohol. Generally, bases are soluble in organic solvents and alkaloidal salts are soluble in water. Due to their basic character, alkaloids react with acid and form salt. Strong bases form salt with weak acid, weak bases form salt with strong acid, very weak bases form insoluble salts. Example, caffeine, narcotine and piperine. Amphoteric alkaloids also can form salt with both acids as well as alkali. Example for this is morphine, which contain phenolic group. So these are some of the examples of alkaloid and or its salt And these are the examples of solvent where we can take the solubility and form salt with base or acid. Carboxylic group, narcotic alkaloid that contain carboxylic group is a niracine, which occur commonly in opium plant. Alkaloids are decomposed by heat except stretchine and caffeine, which we call they are sublimable, and when they decompose they are allowed to stand at a room temperature above 700 degree for longer time. Sensitivity varies in degree with the different alkaloids. Decomposition occurs rapidly and easily when alkaloid is in solution, when it is in dry form. Most tertiary amine alkaloids are easily transformed into the N oxides. Weak alkalis liberate alkaloids from their salt, example ammonia. Strong alkaloids, say for example NaOH and KOH, form salt with phenolic alkaloids. Hot alkalis results in the hydrolysis of ester alkaloids, say example atropine, cocaine, phystogamine, and cleavage of lactone ring. If present, they produce the corresponding acid, example pilocarpine, it is transformed to pilocarponic acid. The basicity of alkaloid is mainly due to the presence of lone pair of electron on the nitrogen. The basicity is increased if the adjacent group is electron releasing like alkali. The basicity decreases if the adjacent group is electron withdrawing like carbonyl or amide group. Next part of our discussion is extraction of alkaloids. This is Stas-Otto method. The technique involves the distribution of alkaloidal bases between acid or aqueous solution and immiscible organic solvent. In the stage 1, the powdered alkaloidal material is moistened with water and mixed with alkali like sodium and potassium carbonate, ammonia, lime, and make paste with water, dry and repowder. The concept is lime or calcium hydroxide combined with acid, tannins and other phenolic substances and sets free alkaloids. So these are the some of the steps which are involved in the extraction of alkaloids and containing alkaloidal salts. In the stage 2, thus extract free alkaloids by hot continuous percolation with chloroform or any other organic solvents. Concept is the free alkaloids dissolve together with other substances and become soluble in the solvent. In the stage 3, they agitate with chloroform solution with successive portion of dilute sulfuric acid and separates the aqueous layer before adding the next portion of the acid. The concept of this point is the alkaloids are converted into alkaloidal sulfates, which being soluble in water and pass into aqueous solvent. In the 4th stage, mixed with the aqueous liquid alkaline with ammonia and collect the precipitate that forms, wash with water and dry. Concept is ammonia decomposes alkaloidal sulfates